Hi, so today we're going to be talking about how to make your applications production ready. Last time we made a application where we could make a voice agent and you could run it locally. That's great. It's great to play around with, to learn and sort of build to start. But really when you want to actually ship it and make it scalable, you're going to need certain things that are allow it to scale. And one of the first things that you're going to hear is you're going to want to use a containerization thing. Generally, Docker is the go-to. So I'm just going to be talking about Docker, what it is, and why it's used, and then maybe go through a little bit of how we can build one out for the agent that we built last time. So what is Docker? They tend to use most people tend to use this sort of shipping containers, and honestly, it makes no sense to me. I chose to just keep the visual so most people could sort of relate to that. But what makes a lot of sense to me is it's a way that you can set your variables so that they're all consistent. Like let's say you're running a scientific experiment. You tend to set all these sort of um, standards that are existing so that everyone can follow along with the same script. You have the temperature set so you know what temperature the room should be. You have all these certain things that might be important in making sure that the results are repeatable. That's what we really need, results that are repeatable. Um, so when you're containerizing, that's basically what you're trying to do. Now, what's the benefit of a container versus, let's say, a VM? One of the biggest things that really most people will know is a virtual machine, because that's essentially if you can run it in one machine and you just create a virtual machine that's the exact same, you should be able to do it. But the benefit of having a Docker container is that you can actually share your host OS kernel, so it's a lot more lightweight. You're not really running a whole new virtual machine that you have to start up every time. It's a lot smaller and it's a lot quicker to run, a lot more lightweight, not as much, stuff to actually start up and build and have all that sort of extra space that's taken up on your machine. Like I said, it's ensuring identical runtime. It's more like, your scientific method, making sure that you have all the rules that you have to follow and make sure that you're in the same environment. Um, and again, with Dockerized containers, you get a little bit added benefit. Now, every application can be isolated into their own container. So if one of the applications go down, it doesn't affect the rest of the applications. And then because they're container images, there's just like with GitHub and with all your other sort of things, there's version control. And lastly, you can really run containers from any platform. So that's really nice and it's really convenient. So now let's get into coding the Docker agent. From the Docker agent, what we're going to be looking at is first we're gonna create a server where you can call that server function so that we can actually run it. The reason we're going to do that is basically in relation to how a pipeline for this should look. What that means is, let me just pull this down right here and I can show you. So what we have here is we have a basic pipeline that Pipecast has shared with us, how they expect it to run. And I think this is a pretty good orchestration of how most of these agents should run. You're going to want something to call the function to actually have the agent go live, because you don't want the agent running in the call 24/7 if it's not being used. It's a waste of the minutes that are just sitting there for the room, for any other sort of features that you might be paying when this is all set up. So making sure that it's only live when you need it, you send in the call to get it running right then, and then the agent will boot up and get ready. So first we're going to be building that out. So now let's actually start getting into the coding. For this, we're going to do a few things. First and foremost, we're going to be looking into creating a server, like I mentioned earlier. So let's get into that server. Originally, we had a runner, which sort of set up our whole daily room and allowed the agent to join the room itself, the WebRTC call. Now we're going to add a server so that we can actually, send those webhook calls in and we can just get the room and agent set up right away. Anytime we want to set up an interview, and we can do this several times, so we can have several interviews running if you want to figure that out for how to scale that out separately. Right now, we're just going to be talking about how to build out that server to start with, as well as how to create Docker containers which can run those servers. So first, we're going to have the server.py, and we're going to be using Fast API for this. That is one of the standard practices for building out any sort of servers using Fast API if you're running it in Python. and we're going to be using, again, I think here we have it called main. I think I will change that here actually before I actually start doing that. We're going to call it start interview bot, and I'm going to make this start interview bot, and so we're going to save it on both sides, and I think down here we're going to have to save it as well so that as soon as main is called, we're starting the interview bot. Reason I want to call it that is because I feel like it's a little more descriptive than main. Anyways, so here we're going to create the fast API. For fast API, looks like we should be good to go. I don't believe the requirements are anything necessary. Interview bot is one of our own things, so it shouldn't cause an issue once we actually start running with it, I believe. We will see as, oh yes, we do have to do one thing. So here I did make a mistake last time. I should have titled it with an underscore. I will be pushing that change shortly, just because in Python dashes don't work as well, so underscores are the standard. App.post. So we're going to be doing a post call, and we're going to want it to be the start interview bot, right? Or we can even just call it start interview. We can have that be the endpoint that we're calling. Since we're using localhost, you could do it through localhost. I'll also show you a way how to, using port forwarding, set up something like ngrok and have a URL that you can call, so you can run it through Postman or anything. I'm using Kodi to do some coding, Sourcegraph's Kodi. So if you see some sort of tabs that are auto-completes or whatever, that's what you're seeing. I will be writing it out for this specific tutorial, but if you would prefer, for me it's much easier to use the autocompletes or even the coding chat. I really enjoy these, and it's really useful. Not sponsored content by anything, just pointing it out if you see it. Anyway, so I'm going to be writing this out. So we're going to create a method that actually starts the interview. We're going to using a try catch method, as it suggests here itself, because it knows there's a possibility for an exception where something goes awry and something doesn't happen. Actually, mostly we're going to be using something like this. We're going to have it await the start interview bot. So we're going to have it run that sort of thing, but we're waiting for the results. And as soon as we get the result from it, which we don't have a result yet, but we will be adding one, we will then return that result, except, we need to return the result into something to return the result, except if there's an exception. And, I did not mean to do a full autocomplete there. If we get an exception, we want to raise that exception, and it will be an HTTP exception error. And we want the status code to be 500, and we want to give the details of what the error was. Pretty straightforward, very simple server. This is how you can basically get a server. Now, to make the server runnable, I like to use Uvicorn. I think it's I like the sort of interface that you see on the screen and everything. So I'm going to be creating another file called run.py where you can actually run it. So Uvicorn is what I like to use. You create a server, uvicorn.run server app host, and here, I was not supposed to, let me write it all out. So uvicorn.run, and we're going to be using server app, and we don't necessarily need to provide the host because we're going to be using localhost, and it's defaulted to that, so I'm going to skip that one actually, and we're going to set it to 8000, and I like to use reload equals true. So the reason why I like to use reload equals true is reload equals true allows you to essentially make any changes to your file as you have the server running, and the server will just automatically reload those changes just a little quicker, so you don't have to stop the server and rerun it. And then here, just like we did last time, we want to check if we're running the main method, so that if we are, we can then we can then make sure that the server is running. So what that means is essentially if I just run like python run.py, it knows to run the server method. That's it. So this is basically how our server is running. So if you want to see it running live, I think before we do that, I have done this before, so there are some requirements we will have to add. I know it's not showing it here, but trust me, we will need some requirements. So first we will be needing, I believe, Fast API as well as Uvicorn. So let's make sure we install those. I know I've already installed them, but just making sure those are installed. And then once those are installed, then you can run python run.py. And so as you see, we have a server here that's up and running, perfectly functional. Now we will be making some changes to the interview bot. Like I mentioned, we do need to return a value. And in returning that value, the best way to do it is actually to do some sort of analysis using an LLM to sort of do some analysis. I am feeling a little lazy, so we're just going to return a static value. So we're going to use json.dumps. json.dumps is essentially, how do I say this? It is a... json.dumps is how you can send across values as a JSON file, as a JSON object instead of as, so we're gonna have to import JSON for that. So instead of just sending across a dictionary as you would in Python normally, you want to make sure that it's sent in JSON format, so you just use json.dumps to do that. And as you see, as soon as I made those changes, I started the reload and it shut down the server and restarted the server. Does it very quickly, very cleanly. I also would like to probably give them a score. So let's do that. Oh, sorry, not here. And we'll give the score of, let's say, 1.0. They did amazing, 100%, cleared the interview. We're just leaving it standard. And generally for the status, we probably want to give a numerical value if it passed. So 200 is generally something that says, yes, we succeeded. And then the score would be 1.0, and then message this is probably unnecessary. We could probably get rid of that. And as you can see, every time I'm saving, like I said, it's constantly reloading it. So we have that as our status, our score, and then we can also probably pass along the participant name if that matters. For this scenario, we're just going to leave it simple, not worry about any variables or anything that's just making it hard-coded to make life easy. But again, those are all possibilities to work with. Now on the next part, we are going to be looking at building out how to actually run a call to, sorry, my apologies, did not need to open up Runner. We will be figuring out how to actually run an interview call. So when you are wanting to see an actual interview happen, right now we have a server that's willing to take in those endpoints, but we're not able to actually run those endpoints. We want to actually do that. So to do that, we're going to import AIO HTTP as well as async IO. These are just ways that we're going to run, basically call our local host and do it. So we're going to use an async method, and we're going to run that, which is just going to be, first we're going to get the URL, which is going to be our default address, which we are going to do localhost 8000 interview. Oh wait, sorry, not interview, start interview. Right, that's our default URL where we can hit that endpoint. I don't know why I wrote async IO. That should just be async def. All right, and then we have to actually create a client session, as this is doing. And with that, within that client session, we're going to actually run the post call, as you would do on Postman or any sort of API call that you're doing. So we're going to be running this post call, and if we get a good response, if the status is 200, then we know we did a great job. So we get the result equals response.json. And if we got the result, then we can print interview when finished, and we can print interview not finished, sorry, result, and we can print out the result. Right, I mean, just basic. And if it fails for any reason, we can say the response.status, we can print the response.text, and we can also just print that interview had an issue, or an internal error, some issue. Let's just say had an issue, right? And so now this is all saved. Last thing we need to do is if, again, we want to make sure that we're getting, oh, sorry, I did not mean to autocomplete. If we are getting the main method, if we're calling just the file itself, that we call this main method, and we want to run it as a async function. So we're using async IO to run an async function. Basically, that's it. Very straightforward. Now we have, I think, all of the steps we need to get it up and running. So let's try running it now. So we have our server running, everything's golden. By the way, I did change my .n variables because last time I did delete those and change everything. So just letting you know up front. And then here I've put them in. I'm not going to show those to you, but we do have the .n .example, so you can see those. These are the ones that we're using for now, and I will need to start up Olama. So I've started up Olama. Now everything should be functional. So hopefully everything goes well, and we're gonna run the interview right now. And so now the call should have gone here. Wow, we got a lot of good messages. We're saying everything's set up. We got the interview started. Let's see if we're good. So there's my video. Now we have all of this set up. So let's try joining it. There might be a delay in what you're seeing. Hopefully it's all real time, we will see. And hopefully you guys can hear the audio. Hello, is anyone there?
I'm here. I'm a large language model, so I don't have emotions or feelings like humans do, but I'm always happy to chat with you. What's on your mind today? Do you want to talk about something specific or just shoot the breeze? I'm all ears, or rather all text.
So it looks like it's functional. It looks like we're getting good output and it is hearing us. So I'm going to leave this call right now and we're going to see if we can get a good response. So we've left the call. It's giving us a 200. Okay. And here it looks like interview finished and interview result. We got it. It's beautiful. Everything seems to be working perfectly. So now we've got the server perfectly functional. Now, server's only half the job. Now we need to make sure that we are actually building out the Docker container. Oh, actually, before we go to the Docker container, let me show you something cool. There is a way to forward ports. So you can just change your port, set in your port here, and through VS Code, they'll give you the option to do port forwarding, or you can use I apologize. You can use ngrok or something to do some sort of port forwarding, and you'll get a live URL that you can use. Just make sure that if you do it through here, you set the thing to public, and then you can change right here. You can copy this URL, and when you're going to your URL here, you can change this URL to be the actual URL that you have, and you can run it the same way from any machine. It doesn't have to be localhost now, and so someone else can hit this endpoint and start the interview. Just pretty cool. You can run it on Postman or something. Just thought I'd show you. Gonna delete this one, and we are not gonna be running that for now. But yeah, anyways, so let's go and build our Docker file. So Docker file is basically how we set up our Docker container, and we need to make sure that it has certain things so that the Docker container can run. Like for example, we need Python, and we want to set a specific version. So we set this version, Python 3.11 Bullseye. It's not a very heavy Python version of the Python 3.11 package, but it's not the lightest version. It's a nice version, and it gets all you the basics things that you need for Python to get things running on Docker. Then we're going to be opening up port 8000 for HTTP service. And so all we need to do there is expose 8000. We can also set an environment variable so that if we have something, for example, in here where we're asking for the port and setting the port accordingly, we could have done that. But considering we're not doing that, we're just going to expose it here. Then you need to install all your dependencies. I apologize, I told you I would type it in. Very used to just having autocomplete. But for that, we're just going to copy all of the .py files because those are all going to be very important. And we are also going to copy the requirements.txt file into the Docker container, and then we are also going to run pip, and we're going to use pip3 because it is most likely going to be a pip3 install. But before we install, we want to add some flags, and the reason we're adding all these flags is because we want to do a fresh install every time so that it doesn't have any sort of cached installs or anything that could cause some weird functions with different versions of Python or anything. We want the correct versions, and we want to install a model, specifically the Celero VAD model. And for that, we're going to create one more file. We're going to call it install models.py, and then we're going to start the fast API server. And to do that, just run the command python 3 run.py like we've been doing to start our server down here. So this is your Docker file. It's pretty straightforward, just goes through that. And the last thing, like I said, we need to make the install models.py file. And for that, we just do import torch, torch.hub.load, and we're loading in this repo, origin destination, our directory, sorry, and the one we're using is sneakers for Celero VAD. This is because Celero VAD is not necessarily a built-in thing to anything, so we're making sure that Celero VAD is downloaded and set up, and then we're also making sure that it's a fresh install every time so that we get the cleanest version of it and everything. And that's it. Now we have our Docker file ready to go, and I'll be pushing this to the main GitHub repo so you guys can see all the changes. And if you have any other questions, please let me know. I hope you guys enjoyed this video, and if you want more like this, definitely give me feedback, or if you have any sort of feedback that you want to, or if you want me to talk about a different project or code with you, or go through everything in a slightly different fashion, let me know. I hope you guys enjoyed this. And we will